Hi, I'm Paul. We're doing Leetcode must-know interview questions. Today's challenge: find first and last position of element in sorted array. Medium difficulty. Let me think about that. Yeah, I mean, maybe. It's I don't know. Maybe at the high end of medium. Given an array of integers nums sorted in non-decreasing order, find the starting and ending position of a given target value. If target is not found in the array, return -1, -1. You must write an algorithm with O log n runtime complexity. Okay, so that takes out of play the obvious solution, which is, to just iterate through the array, start at the beginning until you find the target, and then see how far it goes. Return the return the indices. We can't do that, and so I mean the challenge is it's a binary search, but the number is potentially going to be in there more than once. So another thing is, what if you find it? I mean, how do you know? Did you find the first one? Did you find the last one? Did you find one that's in between? Okay, so that's what we have to deal with. Let's look at this. We'll look at example. Why can't I move that up there? We'll look at example number 1. Yeah, because 2 and 3 are just examples of failing cases. So we're going to write actually 2 binary search routines. They're going to be very similar, and if you were clever, you could probably just write one and pass in a variable to indicate whether or not you're looking for the low or the high one, and proceed accordingly. But we're going to do it kind of the simple way, not the clever way, and we're going to write 2 methods. But to see how it works, here's the binary search. We have to find the first and last element. So let's take a look at that. Here are the parameters of interest when we're doing binary searches. One is low, one is high, and one is mid. So to start this, we are going to send in low. Well, we'll start with low is 0. High is going to be, let's see, 1, 2, 3, 4, 5, 6. It's length -1, so that would be 5. And mid is low plus high divided by 2, so 5 divided by 2 is 2. Let's indicate where that is. There is index 2. All right. So the first thing that we're going to look at, because we're looking for the first element. So first of all, we're going to say, is mid equal to 0, or is the element at mid greater than the element to its left? In other words, mid -1. And actually, neither one of those is true. But what we're trying to figure out is this the first element? Now, if mid is 0 and we found the target, then it's definitely the first instance of the target because it's the first element of the array. Also, if we find the target and we look at the preceding number and it's less, then we have found the first number. I mean, yeah, the first occurrence of the target. Neither one of those is true. So we move on. What's the next possibility? The next possibility is that the target is greater than the number that we're looking at, 7, which in fact it is. So we are going to toss the left side of the search space. And we're going to do that by setting low to mid plus 1, right? So everything from mid and further to the left is gone. Now we have low and high. 3 and 5, that means we have to recompute mid. Mid is now going to be 3 plus 5 divided by 2, and that is 4. All right, so we go through again. Is mid equal to 0? No. Is the target, oops, you know what? I should redraw the number that we're looking at here. We are now looking at index 4 right here. Is the number that we are looking at greater than the preceding number? Actually, no, it's equal to the preceding number. So that means we didn't find the first number. We didn't find the first 8. All right? What is the next possibility? Is the target greater than the current number, 8? No, it's not. So we are going to toss the I'm getting confused. We are going to toss the right half of the search space. Okay, we are going to toss from where that 8 is to the right, because those aren't the numbers that we're looking for. Okay, how do we do that? Well, we set high to mid plus 1, right? 3, 4, and then we recompute mid. It's 4 plus 3 divided by 2, and that is 3. All right, let's redraw that. And 3 is here. Okay. Is mid equal to 0? No. Is the target equal to, is the target greater than the number to its left? Yes. Is the number that we're looking at equal to the target? Yes. Well, in that case, problem solved, because this is the answer. That's the first 8. Okay, we hit the target, we looked at the preceding number, and we saw that it was less. So this has to be the first 8. All right, so that's the first, we got the first number. It is, the first index is 3. All right, let's take a quick look at how this will work if we're trying to find the highest instance of the target. Okay, I'm going to erase that. Reinitialize the indexes. We have 0, we have 5, and we have 2. All right. Is mid equal to num's length minus 1? It isn't. Is it less than the whoa, 2. It's right here. Is it less than the number 2? It's right. Yes. Why do we care about those two things? Well, if mid is equal to if mid is equal to num length minus 1, that means we're on the last element. And if mid is less than the number to its right, if either of those is true and we hit the target. Now, in this case, we didn't hit the target, But if either of those is true and we hit the target, then it has to be the last instance of that element. And in fact, we didn't hit the target. That 7 is not going to work. What is the next possibility? Next possibility is the target less than array at mid? And it isn't. So that means we are going to have to throw out the left half of the search space, and the way that we do that is by setting wait a minute, is target less than no, it isn't. So we set okay, regrouping. I think I said is the target less. I think I said that the target is less than what we're looking at. The target is not less than what we're looking at. So we got to toss out the left half of the search space here. And the way that we do that is by setting low to mid plus 1. And that is 3. And we recompute mid. 3 plus 5 divided by 2 is 4. All right. Now we're going to go again. Let me repoint the mid pointer. Mid is now pointing here. All right, now is mid equal to num's length minus 1? No. Is the number to the right of mid greater than mid? Yes. So then we got to look and see if we hit the target. Is that the target? 8. Yes, it is the target. Not only is it the target, but the number to the right is bigger. So that is the last instance of the target. And so we can return mid 4. So the answer is, in the first case it was 3, in the second case it was 4, and that is the answer that we're looking for. Let's see what an implementation would look like. All right, I'm trying to think what to call these. First, I don't want to call the variable first and the method first. So let's do like int start equals first. That'll be the method name. First, what do we need to pass to first? We need to pass the array. We need to pass high and low. It's recursive, so nums dot length minus 1, and what else? The target. Okay. Let's go ahead and write that. It's going to be, I mean, actually here, let's do this, but we're going to have int start, we're going to have int end. This method we'll call last, and the inputs are the same, right? Yeah, inputs are exactly the same. All right, so this is going to be private. It's going to return an int. We'll call it first. The inputs are int, let's say array, int low, int high, and int target. Okay, that's good. If high is greater than or equal to low, then we're still okay. We're okay. If they cross over and we haven't returned anything, that means the number isn't there. So at that point, we return -1. All right, so inside this, we'll compute mid, which equals low plus high divided by 2. All right, now we want to see if this is the, well, let me just write it. If mid equals 0 or target is greater than array mid minus 1. Am I going in the right direction there? Target is greater than, yes. So if either of those is true, and array mid equals target, then it's got to be the first instance of the target. So in that case, we can return mid. All right, what are the other possibilities? Well, one other possibility is that the target is greater than array at mid. If that is the case, we are going to throw out the low end of the array, and we're going to make another call to first with a subarray. It's going to be very much like that, but in this case, first, and we're calling it array down here. First, array low is going to go to mid plus 1. Yeah, nums length minus 1. Yeah, but we're calling it high here. And the target. Okay. That's good. Wait, I need a semicolon there. Else. The other possibility is that we are throwing out the top half of the array, in which case low would still be low, and high would go to mid minus 1, and the target stays the same. All right, that looks okay to me. Let's do first. I'm going to copy this because it's going to be very similar. So let's call it last. The inputs are the same. The array, low, high, and the target, same thing. If high is greater than or equal to low, we can keep going. Compute the mid the same way. Now in this case, what we care about is if mid equals array length minus 1, or the target is less than the, I'm going to go to mid plus 1, is less than the number to the right. In that case, if we have the target, if we're looking at the target, then it has to be the last instance of the target, and we return it. What are the other possibilities? The other possibilities are that the target is less than array.mid, in which case we are going to throw out the top half. Let's see, the target is less than what we're looking at. Okay, so we're going to throw out the top half of the array. So that stays at low. This goes to mid minus 1. And actually this should not be first. This should be last. And this should also be last. And in this case, we are throwing out the bottom half of the array, or the left half of the array. So that goes to mid plus 1, and this stays at high. All right. I may have gotten confused a little bit on the naming there, but let's try and run it and see what happens. Compile error, missing return statement. Oh my God, there's not a. Oh. Well, wait. 6. Line 6, there's not a missing return. There's a missing return statement. Oh, right. Yeah, I meant to go back to that. Sorry. Okay, you know what? I think actually if start equals -1, that means the number isn't there. And if it's not there, there really isn't any point in doing the search for the last instance of a number that isn't there. So if start equals -1, we could just go ahead and return an integer array, new int, I've lost my recording device here. Oh, there it is. No, yeah, it's still going. Okay. Couldn't see it. I think at that point we can just return -1 because the number isn't there. All right, and then we'll do int, and then we will do, it's going to be very close to this. Then we can do this. We will return first. No, not first and last. Start and end. Start and end. Okay. Try that. Wrong answer. Ah, wait a minute. Oh, that output -1. Whoa. Okay, hold on a second. All right, rookie mistake, and I hope this fixes it. But there should be a return here. I shouldn't just be calling this without returning anything. So, return, run. How did that go? Did that work? Well, that's embarrassing. Okay, so let's try and submit. Can I run those without a return? Where are we at here? 9 milliseconds. 0. Is this 0? Not even sure what I'm looking at there. Okay, anyway, that is the first and last, what do they call this? First and last position of element in sorted array. Yeah, it's a binary search. You have to modify it a little bit to, and then there's more than one way to do this, but you need to modify it a little bit to make sure that when you find the target, that it is either the first target or the last target. We used 2 binary searches. Obviously, these routines are very similar, and you could combine them, send in another element, another parameter, I should say, to indicate am I looking for high or low. And what else? Yeah, when you do the recursive calls, don't forget the return statements. Okay, I hope you enjoyed that. This is, yeah, feel free to like, comment, subscribe, and see you next time.